Let's review negative numbers. Let's start with a review of negative numbers. And that key idea, when you're multiplying or dividing two numbers, if the signs are the same, the answer is going to be positive. If the signs are different, the answer is going to be negative. Really, really important idea. If the signs are the same, the answer is positive. If the signs are different, the answer is going to be negative. Okay. Uh, Let's practice a couple of those. Put it to the side there, pause, try these 4 questions. Remember, if the signs are the same, the answer is positive. If the signs are different, the answer is going to be negative. That's how we deal with multiplication and division of negative numbers. So you had your moment. You should have paused. You should have had a go. That's what was supposed to happen. I'll work out 7 3s 21. The signs are the same, so the answer is going to be positive. It's going to stay as 21. For B, what's 40 divided by 5? The answer is 8. Are the signs the same? No. And if the signs are different, then the answer has to be negative. So the answer for B is negative 8. 7 6s, that's 42 if they're both positive, but are the signs the same? They're not both positive, they're both negative, so the answer is going to be negative 42. One is negative, one is positive. The signs are different. And then the next one, why am I saying E there? That means there was supposed to be a question D, which clearly is not there, so hopefully you did E. You have a chance to pause and do it if you haven't. Sorted. Okay. How many 3's go into 24? We would write 8. 8. Are the signs the same? No. So your final answer should be negative. Spot on, spot on. Really key idea. Make a note of this. If this is something you're still working on to perfect, you're not getting, let's say, 99% success. By that I mean, once in a while you might make a mistake, but you have the negative number thing sorted for multiplication and division. That's great. Otherwise, I'll say make a note of this in your book and use it for revision purposes. Let's continue. We're looking at task 33 here, task 33, and now we want to think about that. And I know people mix this up with negative, with addition and subtraction. It's not about signs are the same, negative signs are the same, what am I saying? Signs are the same, positive signs are different, negative. That doesn't apply to addition and subtraction. For addition and subtraction, it's all about the number line, moving up and down the number line. Where's my pen to move up and down the number line? Yeah, that's what I wanted to show you, moving up and down, up and down, up and down the number line, okay? You've been given some facts here that you might want to read, pause, read, and take a note of. In particular, how you manage negative when you're adding a negative number and when you're subtracting a negative number. So if this is something you need to make a note of, please make a note of it. Very, very important idea. Adding a negative number, you do the opposite. It's going down. It's taking away. Subtracting a negative number, it's going up. Okay, very important idea. An idea, you've made some notes if necessary. We don't want to waste time note taking. You're only putting it down, making a note of it if it's something you think, I'm not that confident on this. And let's just check and make that decision about how confident you are on this. By boom, I've left the rules there. I've given you 5. This time you actually have the 5 questions. Pause the video, have a go at doing these 5, please. Pause the video and have a go at doing these 5, please. Right, good stuff. Let's start, and I need to stop rocking. Oh, too much rocking. Right, so let's go with this. I'm taking away a positive number. That means I'm going down on the number line. It's all addition and subtraction is all about number line movement. That's what you need to be thinking about. Going down the number line, I will get -6. B, -4, -5. I'm taking away, I'm starting at -4 on the number line, but I'm going down, so I'm taking away 5. That will give me -9. And it's useful if necessary, you draw your number line and draw a little number line for all of them. If I started at -4 and I'm going down, I'm going further away from 0. Going up would have given me closer to 0, but going down, it's -5, -6, and so on and so forth. So that's how I'm getting to the -9. For part C, that's where things get a bit funny. We're adding a negative number. And from the notes I mentioned, when we're adding a negative number, we move down. Adding a negative number, it's moving down. In other words, adding a negative number is taking away. This is -6, take away 7. If I start at -6, I'm going to clear that. And you want to draw. You don't it's not. I know it's a lot of young people. I know, you know, I see you guys in class, and you get a question like this, you immediately turn and you want to look at the number line on the wall. You need to be in the exam. There's no number line on the wall. You want to be able to build a number line for yourself. It doesn't have to have all the numbers. It just has to have the key numbers you need for your specific question. So if in this case, I have -6, I'm taking away, so I know I'm going down. If I was going up, I'll get to -5 and bigger. Going down, it's going to be -7, -8. And you realize, well, 6, I'm going 7 further away from it. 6 and 7 is 13. What you will get to dot, dot, dot is -13. So if the answer for C, I'll put it in red, is -13. The answer for C is -13. When you're adding a negative number, it is going down. When I'm minusing a negative number, minus and a minus, it's going up. That's the indicator, it's going up. So for D, what we actually have is 7 plus 4, and 7 plus 4 is 11. Finally, for E, I start at -6 and I'm adding 8. This time, adding, you're going up on the number line. You'll get to 0 when you add 6. So you need to add 2 more to get for the effect of adding 8. Adding 8 is adding 6 and then adding 2. That's the best way to think about it in this case. And that means the answer we will get to is positive 2. Positive 2. -6 plus 8 is positive 2. All positive. So that's a recap of negative numbers. I'll do other sessions on this going much deeper, but that should be sufficient for our purposes here, looking at formula for now. And I hope you find that useful. Take advantage of it, okay? Good. Task 34 is what we're going to look at. And I started with a -1, P -1. In other words, what I'm saying is, don't even think about this as an exercise. Just get stuck in and let's just start doing problems. So pause, read, have a go, please. Pause, read, have a go. We have a salesperson, substitution, and let's just run through this. So you've had your moment to have a go. I'm going to go through it really quickly. 4n means 4 multiplied by n. So if it's 30 sales, what do I have? P is equal to, and P is the profit. That's what we're reading, is 4 multiplied by 30, take away 50. 4 multiplied by 30 is 120. 120 take away 50, so the profit is going to be 70 pounds or $70. They didn't give units, so we'll just leave it as 70. For 9 sales, what's going to happen here? P is equal to 4 times 9, take away 50. 9 fours are, 36. Houston, there's a problem. That's less than 50. How do we deal with that? Well, it's a subtraction, and to deal with that subtraction, we start at -34. Sorry, we start at, what am I doing? We start at 36. We want to take away 50. The way I would do that is taking away 50 is the same thing as taking away 36, and then taking away 14, because 36 and 14 would give me 50. So why did I do that? Because I need to take away the 36 to get 0. And then when I take away 14 more from 0, going down from 0, will give me -14. The indication for B, therefore, is that if you made 9 sales, you made a loss. Your profit is negative. Profit is -14. That probably doesn't look as clear as I would like. -14 is your profit. -14 is a minus number, so it's a loss. It's a loss. Damn, you don't want to make a loss, but it happens. It happens. Let's do another. Let's move on. Let's keep going. P0, this time we introduce our friend, the decimal. And at this stage, what I would say is I'm happy for you to use a calculator. I want you to try and do these without a calculator, but if you feel if that's being a barrier to you doing this, do your substitution, use a calculator. Okay, right now that's really important. Use a calculator if you need to. So try this one, please. I'm gonna do it in a moment, but off you go. You have your try. 0.02. 0.02. So we know. So we're gonna use that L is gonna be equal to 40 plus 0.02 multiplied by 50. Now, a tricky one. As I said, you could use a calculator, but 0.02 multiplied by 50, well, 2 multiplied by 5 would give me 10. What we're thinking about in 10, so 2 multiplied by 50 would give me 100, and then you're thinking I need to have 2 decimal places. If I adjust 100 using 2 decimal places, what am I going to get? I'm going to get 1. Just saying that again, how I did it if I didn't use a calculator. 2 times 5 is 10, so 2 times 50 is 100. And then it's not 2, I was multiplied by 0.02, so 100 needs to be adjusted. It made by 2 decimal places. I needed to divide by 100 basically. So 1 is the value, and what we have is 40 plus 1, which will give me 41 as the length. For B, we have T is minus 10. Ooh, yucky, yucky. L is equal to 40 plus 0.02 times minus 10. The minus 10, what do we know? If we were multiplying by 10, we would get 0.2. So multiplying by minus 10, we would get minus 0.2. And where's the 0.2 coming from? Multiplying 0.02 by 10 would have the effect of moving forward 1. That's how we'll visualize it. Moving the decimal place 1 place forward. That's the visualization. The reality is it's the numbers move. So the number moves 1 place to the left is what's actually happening. So what do we have? We have 40 take away 0.08, and that will leave you with 39. I need to go up to 40, so what am I missing from the last one? I'm missing, what do I add 0.2 to get 1? 0.8, so I'm missing 0.8. So 39.8 will be the solution. And on that note, I think you're ready to really get stuck in and do some questions on this. So very first one for you to look at. Very nice decimal. So yeah, I appreciate if you want to use a calculator, but it can be done without a calculator. You're pausing, use the power of the pause, and you have a go at this one, please. Thank you so much. The answer is going to be 18.4. 18.4. How are we getting 18.4? Well, we need to multiply I'll clear that actually. I need to multiply 0.08 by f. So I have 0.08 multiplied by, and in this case f is 20, so multiply by 20. I do 8 2s are 16. I have 16. And then the 8 2s are 8 multiplied by, so 8 multiplied by 2 is 16. I'm writing it down. That means 8 multiplied by 20 is 160. And then 0.08 multiplied by 20. What do I need to do? The difference is I need to go back 2 for my decimal positions. Going back 2 will give me 1.6. So your final version, what we need is 20 take away 1.6, and 20 take away 1.6 will give you 18.4. So that's the question. That's the answer to this question. Let's look at another one. So number 2, a bit of reading there as well. You pause, you have a go at this one, please. Thank you very much. You're having a go at this one, please. Okay, right. Minus 10 is what we had. So let's see. Right, if I have read correctly, the answer you should have is 14, just because I just want to make sure actually that the answer is what I'm giving you. So we have 1.8 multiplied by minus 10, and then we have to add 32. We can deal with this. 1.8 multiplied by 10 would be 18. We're going to have 18 to start off with, but the signs are different, which means my answer would give me negative, so it's negative 18. So what we have is negative 18 plus 32. Order we can change. It's the same thing as 32 take away 18. That's what we're doing. 32 take away 18, and what does that give you? Well, 14. So the answer, 14. 14 is the value of f. For number 2, your answer is 14. Shall we go to number 3? Oh yeah! Let's do number 3. Let's do number 3. Here you go, another one. It's getting a bit more complicated, but it has to, because I want you to practice so that anything they throw at you in an exam, you can boom, 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 make it happen. Boom, 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 make it happen. Yeah? Ooh, all right, off you go on this one. going with this one. Good stuff. You're looking good. Looking good. Looking good. This is number 2. Number 2D. Okay. Right. Let's see. The answer I'm reading is 4. Did you get 4? You should have paused. Had to go. Did you get 4? If you got 4, do the dance. What do we have here? We want a half multiplied by -4 plus 8. And then multiply by 2. That's what we're thinking. That's what the formula is asking us to do. The -4, and I probably put this where the picture is, so I'm going to rub it off, and I'm going to write it at the bottom. What should we have written? S is equal to half u plus v multiplied by t, which is equal to half -4 plus 8 multiplied by 2, -4 plus 8. The signs, number line, we're moving up on the number line from -4. -4, let's just put that in to deal with that. -4, if I add 4, I get to 0. I need to add another 4, because 4 and 4 is 8, which means I'm going to get to +4. So +4, and half of +4 is 2. Half of +4 is 2. And then with the 2, what do I need to do? Let me get that. Half of +4 is 2. So 2 multiplied by 2, which is going to give me 4 as an answer. So for P3, the answer we're getting is 4. The answer we're getting is 4 for this question. And we had, 2D, just making sure we're set up right there. Okay, good. Next one, we got two more before we look at pausing on these particular types of questions. 2 more, keep going. I gave you 4 of these. Oh, I said 2 more. I feel so bad. Did I just say 2 more? Well, a question can have multiple parts. So you got these 4 to do, and then one more, which is okay. Do these, please. I'll put up the answers in a moment if you want to work on these, please. 4 of them. Trust me, I'm doing well. The textbook had like about 10. Which one is A, C, G, and E? Question has about 15 other things for this question. So I'm doing good. I only asked you to do 4. Yeah, I only asked you to do 4. Okay, right. So what do we have? We have, for the first one, I'm going to pop in answers now. I'm generally just putting answers now. You should have 80. Hopefully, if any answer I put in is not correct, please say something. But I think I'm looking at the right thing. First one is 80. Then C, I have to talk about C. The answer is going to be plus or -4. Did you just put 4? Let me just look at this. C is important, so I'm going to look at it. I want the square root of 10 plus 6, which is the square root of 16. And the square root of 16, remember, a minus times a minus gives a plus. So -4 times -4 is equal to 16, just as 4 multiplied by 4 is equal to 16. Hence the reason for that, putting that plus/minus sign in there, because that symbol indicates that you can either use +4 or -4. It's both of them are valid answers. If you only had one, just make sure you put both of them. I want to say you'll get the mark, but GCSE is changing, and there are questions in a GCSE exam paper which specifically check, do you know that the negative number is an answer as well? So it's something you need to nail. Okay. For E, for E, I'm getting -3 as my answer, so that's what I recommend. E -3, and G, all that hard work, and what do you get? 0. So for G, 0 is what you should be getting, and I'll just put that in. We have 2 plus 2 multiplied by -5 plus 8. And yeah, you can see it there. 2 plus 8 is 10. And then the positive 2 times the -5. 5 2s are 10, but the signs are different, so you're going to get a negative. So the denominator is going to be, the numerator is going to be 0. Numerator is going to be 0. I have nothing, so I can't share. I can't give you anything. The answer, the final answer is also 0. The final answer is also 0. Okay. Last one. And it's not parts. I behave. Last one for this. Let's wrap it up. Last one. Calculate the value of f when r is equal to -20. Pause. Have a go. Yeah, you got that one running through really, really quickly. You have 9 multiplied by minus 20 on 4 plus 32. That's what you should be having. Mine, I need to use the actually, you know what? Yeah, I would expect you to use a calculator on this, but minus 180 on 4 plus 32, which will give you minus 45. Minus, what am I doing? Not minus 45. If I split 180 in 4, yeah, it is 45. Yeah, I was right. Minus 45. Why am I second guessing myself? Minus 45 plus 32 is what you're looking at, and that will give me a whooping minus 13. Minus 13. If I start at minus 45, I go up 10, minus 35, I go up another 10, minus 25, I go up another 10, minus 15, that's 30, and then I add on 2, I get to minus 13. So you see how I'm breaking it down into pieces? There's a strategy. You don't need to think, whoa, oh my goodness, numbers are big. How do I do it? You can skip count in tens. That takes you to 30. Then add on 2 more. What do you get? Okay, so those are real strategies you can use instead of just looking and thinking, oh, I can't do it, I can't do it. Yes, you can. Yes, you can. Sometimes you get some rather interesting formulae, like 1 on F is 1 on U plus 1 on V. That's the beauty of maths and science for you. In this case, the unknowns, the variables, F, U, and V, they're denominators. How, if I give you U and V, how do you find F? Not as straightforward as the work we've been doing previously. And it's managing using these more complex formulae. That's what we're going to consider in this task. Right. So let's do one of these. We want to find F, and we are given U and V. And I encourage you, of course, to just have a go. You think you can manage it, pull it off, go for it. I'm going to start, but you can pause me. You can get started and then watch what I do after and see if it was the same and make your adjustments. That's the best way to learn. I keep telling you all that because it's so important. So I'm like a broken record. I keep saying it, and you're thinking, oh, I got it. Well, just keep doing it. Okay, we're all good. We're all good. Let me begin. I can write then I have 1 on F is equal to 1 on U is 10, 1 on 10 plus 1 on 8. Now I have 2 fractions to add. To add fractions, the denominators have to be the same. So I'm asking myself, what's the lowest common multiple, the smallest number that is in both the 10 and the 8 times tables? And the answer to that, the one that's coming to my mind, is 40. So I'll put 40. What do I multiply 10 by to get 40? Multiply by 4. So the 1 has to be multiplied by 4 times 4 times 4. And similarly, 8 times what gives you 40? 5. It is 5, so plus 5. So 4 plus 5, I'm getting 9 on 40. 9 on 40. So 1 on F is 9 on 40. But hang on, I don't want 1 on F, I want F. So what do I have to do now? Well, if we have, and I'm just looking for space here, if I have 1 on F is equal to 9 on 40, that means that F on 1 is equal to 40 on 9. Slick. We can invert the left-hand side, invert the right-hand side. Use the reciprocals of both of the expressions. Do I say expressions for these? For the terms? Both. No, it's expressions. There's a calculation, so they are expressions. Okay, and F divided by 1 changes no value, so it is F. So F is 40 on 9. Now, nowhere in this question says to give F as a mixed number. I have a top every fraction. My job is done as far as I'm concerned, but some people like to look extra pretty. They don't like to look at the top every fractions, so they'll do how many 9s are in 40, and that will be 4. And what's the remainder? It will also be 4. 4 and 4/9, that is the value of F. 4 and 4/9. And that's how, so you can see how all of a sudden it gets way more complicated than what we're looking at in task 34. But it's doable with just some concentration, some perseverance. Okay, let's look at another one. The fractions, that's one that can do your head in. The other one we can deal with is the squares and having to square root. So let's see, z squared is x squared plus y squared. And you're probably thinking, hey, that's like Pythagoras. A squared is equal to b squared plus c squared. And I'll say, yeah, it's the same thing. I just use different letters. Well, the textbook used different letters. I'm not actually sure why, but hey, whatever. Ooh, look at those numbers. You got a calculator? Make it happen. Make it happen. Come on, deal with it. Deal with it. But write a nice story. Your chance to go. Your chance to use the power of the pause. And for me to do it as well. Well, for me to get going. You should have paused and tried. Z squared. What we'll do, we'll substitute is equal to 3.6 squared plus 4.8 squared. And you can probably work out those individually and add them up. But yeah, if you want to do that, that's cool. What I would do is I would just say that that's z squared, which means that z, which is what I want to find, is going to be the square root of 3.6 squared plus 4.8 squared. So I'm just bundling it all into one, and I'm just going to put that whole calculation into the calculator. Square root of 3.6 squared plus 4.8 squared. And the answer, I'm just going to check the answer. I don't know what it is, but I just know how to do it. You know what I'm saying? The answer is going to be, wow, I did not expect that. That's deep. That's deep. The answer is going to be 6 or minus 6. The calculator is only going to give you one answer. That's what's going to happen on your calculator. That's what I expect to happen, but I will double check. Some of these new fancy calculators do things differently than in my day, so let me just make sure I don't get myself in trouble with that. The key thing is you need to be aware of the fact that you're doing a square root. So we talked about it earlier in one of the earlier tasks where you want to be putting 4.8 squared. You want to be putting the negative value as well. So the calculator only gives you the positive. As I was going to say, you need to think, well, hang on. This is not actually officially a Pythagoras question. Nobody gave you a story or context about length. They just said z squared is x squared plus y squared. So z could be any number, both the negative or the positive. When I say any number, either value that fulfills the equation. We cannot ignore the negative number. Be very careful about this with squares. I'm almost sure it will be in your exam paper somewhere where they'll ask you you'll have some work doing with square numbers and square rooting, and if you forget the negative sign, the negative value, you will lose a mark. That mark can make the difference in your exam, so be very, very careful with it. And at that stage, I'm thinking any other big thing for me to tell you? No, it's just off you go practice. You've looked at the situation with the squares, we've looked at the situation with fractions and having to do the inverting, doing the reciprocal. I think we are sorted. So yeah, I'll pop over 4 and answers, and yeah, we should be sorted. So this is your first one. 2, have a go, pause, have a go. Do the hard work. Remember, you have to invert the fractions. It looks ugly, but it's doable. See what you come up with for those, and that is number 3A and B. 3A and B. I will whiz bang through it. You have the power of the pause. Use the power of the pause and do it. It is my chance to whiz bang through it now. What should your work look like? 1 on Z is equal to 4 on 4 plus minus 10. And you're working out that. You have a calculator. That is 4 on 4. Take away 10 is minus 6. So 4 on minus 6. Which can simplify to be 2 on minus 3. And then I will invert. I will do reciprocals. So z on 1 is equal to minus 3 on 2. Note what I've done there with the minus sign. All that was in the denominator. The reality is when you're writing a fraction, the negative sign, you just line it up with the, it doesn't matter. Think about it. For it's division. Doesn't matter which number is negative. No, it doesn't matter if the minus 2 is negative or the minus 3. You're going to get the same answer if you do the calculation. Check it if you don't believe me. And on that basis, the convention is that you put the negative sign in front of the fraction halfway, like in line with the fraction bar in general. So z on 1 is minus 3 on 2. I did not have to write z on 1. I'll just clarify and say that that is z. So z is minus, whoa, don't forget the minus sign, minus 3 on 2. For the second question, it's a similar process you should have gone through in terms of adding the fractions and doing the reciprocal. And from what I can see here, the answer you should get for B, so for B you should have 12 on 25. 12 on 25 is what you should have for B. Shall we move on? Okay, so 12 on 25 is what you should have for B. Let's move on. Okay, next one for you to do. Whoa, not 1, not 2, but 3 fractions. And those of y'all physics, you need this for physics. Resistors, this is real. This is not a made-up formula. You need to be able to use this in physics. So off you go. Off you go there. Let's Q5. And, oh, hang on. Wait up. You can't do the question, can you? Because you don't have any values for x, y, and z to substitute. Let me fix that. Ooh, how did that happen? All right, we're gonna sort that out. Yeah. All right, there you go. Is that what you were expecting? So here you have a set of values for x, y, and z. Now you can pause, and now you can have a go. You now actually have values to substitute. Oh, calculator's your friend. Do you really need it? You decide. Okay. So you've done this one. Let me go through it now. Let me do my bit. X, Y, Z, 1 over 1,000 plus 1 over 5,000 plus 1 over 2,000. And you're thinking, what's the you're gonna have to scale up to 10,000 to get your lowest common multiple. So I'm gonna use 10,000, which means I'll have 10 plus doubling 5,000 to get 10,000. So I'm gonna have 2. Then multiplying by 5 to get 10,000. So I'm gonna have 5. So overall, you're getting 17 on 10,000. That's what 1 on R is 17 on 10,000. So R is 10,000 on 17. I can't go any further than that without a calculator. No, I'm not going any further than that. So at this stage, I'm going to sneak peek at the answer. So you got 10,000 on 17. Now the challenge is for me to identify the right question, and it was number 5. B. So let's see, calculator, 1, 2, 3, 4 zeros divided by 17. Boom. Yep. And the answer you get, you can see it on the, can you see it on the calculator there? That's what you should have on your calculator display, if you can see that on the screen. Actually, you can't see that properly because the box with me is too small, isn't it? So that didn't make any sense at all. Ooh, right, so what do we have? We have, I'm looking for a color, the answer to find the value of R. R is 588.24. 588.24 is what I'm going to use. The 2 decimal places, I've rounded it there. Okay, good. Let's do another one. And hopefully you can actually see how this is way harder than the previous ones. It's just the complexity of the formulae to manipulate, to manage to do the calculations with. And here you go, another one, number 3. You have values, you have an expression to work through. Substitute. You're using a calculator. Off you go. And for this question, you should get, if I am checking correctly, you should end up with 33.5. 33.5 is what I'm seeing here. 33.5. One more for us to finish off. The last one. It's part A and part B. And this is hopefully it's question 7. Okay, right. Pause, you're having a go, you're working through this one, please. Thank you very much again. And I'll pop up the answers for you. For A, you should have, whoa, something almost fell there. That's never good. Don't worry. Not a crisis, it's all good. For A, you should have minus 32.3 3, that's giving the answer to 3 significant figures. So you're keeping the first 3 digits that are, you start counting from non-zero. That's how you do significant figures. So it's not 3 decimal places. You start counting from the first digit that is not 0. That's how you do significant figures. And for B, you should have minus 30, minus 30. Perhaps these, because they go into significant figures and whether your answer is reasonable, etc. Check, they'll ask you to do a check, and to show you working. But minus 30 is a key figure when you do the calculations. Then minus 30 is what you should be getting, and minus 32.3 is close to minus 30. That's what we're trying to get across there. Okay, so when you do the rounding, in other words, you should have been working with 15 and you should have been working with minus 10. Those are the figures you should have popped in, and you should get minus 30, okay, when you work through. Good stuff there. That's it for using formula. You get in touch with teachers if you need additional support and questions on this, or if you want more practice. We've got lots more questions we can use, but we have to find a balance of what we can do in a reasonable time frame. So that's it for task 35. The next bits, once we can use formula, it's about constructing formula is really important, being able to construct formula and also being able to rearrange formula. So those are the other bits that we want to look at going forward. Okay, that's it for now.